Hello, everyone. Good morning, good afternoon. Welcome to yet another informative webinar by Impetus. I'm Lisa Glenn, your host and presenter for today's session on harnessing the cloud for performance testing. We're going to share with you how the infinite computing power of a cloud infrastructure can be leveraged for flexible, scalable, and affordable load testing. Today, we have Shirish Pillai, Director of Performance Engineering from Impetus Technologies, as our expert speaker. Now, Shirish heads the performance engineering function at Impetus and has been involved in the various R&D initiatives in this domain. He's played a pivotal role in the development of SandStorm, our enterprise performance testing tool. Now, let's go ahead and have a look at what today's session has in store for us. The cloud-based performance testing has suddenly become a buzzword today. From startups to large enterprises, everyone is trying to make the most of the opportunities offered by the cloud. And really, why not? You just can't ignore the distinct benefits that a cloud infrastructure offers. It enables faster time to test, it's highly scalable and as an on-demand solution, and it also reduces the overall performance testing costs. Today's session will share insights on the various benefits of using the cloud for performance testing, as well as how to address the various challenges associated with this approach. This session will also discuss the different models where performance testing tools can be deployed on the cloud, in addition to some of the best practices and real-world experiences. Now, before we dive deep into the details of the cloud-based performance testing, let's just take a minute to understand why this is emerging out as an important paradigm in performance testing. Now, as you all know, the Internet is growing at an unprecedented rate. Globally, there are close to 2 billion Internet users, and this is just a phenomenal number. Facebook has crossed the whopping 500 million user mark, and Twitter receives millions of tweets every month. The usage of web and mobile applications has also increased phenomenally with the availability of devices like smartphones, netbooks, and iPads. Now, where on one hand, this is making life very easy for the end users, it is an altogether different story for the application architects and developers, as they have to ensure that their applications are performing efficiently and effectively under this huge load. Moreover, the concern area is not only the 2 billion users that there are on the Internet, it's also the increase in the size of the data. We're working with a customer in the Internet measurement space and have experienced that the data size has gone up from hundreds of millions of rows to billions of rows per day just in the last 1 year. We're now going to discuss the challenges and consequences of this growth in the user base and data size. We know that application performance directly affects your bottom line. For example, if you're in the advertising business, how much you earn is directly related to how fast the ads are getting displayed on your website. We have observed numerous cases where the downtime of a website and the latency of even milliseconds have resulted in revenue losses and customer dissatisfaction. Thus, performance does matter, and organizations do consider it as one of the key attributes for the product strategy. So when you're not sure about the performance parameters or where the application scalability is concerned, moving to the cloud ensures effective management of your performance requirements. Exploiting the power of the cloud for performance testing is gaining immense popularity. Amazon provisioned 18 million EC2 servers last year. Also, the number of users subscribing for other cloud vendors, such as Microsoft Azure, has also increased significantly. But before we discuss the benefits, challenges, and models of the cloud-based performance testing, let us first take a look at the prevalent performance testing model. We will call it an on-premise performance testing model, as all the components involved, such as the performance testing tool, the system under test, etc., are deployed on-premise within a local environment. One of the first steps to conduct a performance testing assignment within a local environment is to set up a test lab. The lab would need infrastructure, servers, hardware, and software to host the system under test and the performance testing tool. Setting up this lab requires considerable investments and efforts and has overheads such as maintenance costs. We would need to hire administrators to maintain and support the lab, and this can further involve training costs for the resources who would be working in the support role. With the substantial increase in the Internet traffic, both in terms of the number of users and the size of data, the critical challenge for the performance testing team is to scale and test immediately to higher concurrency levels. This will call for procuring additional hardware, tool license extension, setting up the tool and other software on the new hardware, resulting in additional capital expenditure, which may lead to a delay in getting the expected performance numbers. Let me now ask our expert speaker, Shirish, on how this affects the big picture. Hi, Shirish.
Hi, Lisa, and a very good morning and good afternoon to everybody. And thanks for all of you for joining us in this today's session. Now, to begin with, let me share an interesting incident with you all. 2 years ago, one of our clients asked us to develop a video streaming web portal with an expected load of 1,500 concurrent users. The client had set up a test environment and has all the required infrastructure. We tested generated performance numbers for 1,500 users. Within months, the client portal was a huge success. The expected load has gone up to 10,000 users. Now, since there were no means to test this volume with current infrastructure, we went into a reactive performance testing mode. So what does this tell us? Many a times the developers, the architects, administrators, and other stakeholders would monitor the production servers, since there is so much of uncertainty involved due to this peak usage. Now, had it been possible to quickly test the system with higher volumes, with additional hardware, we would have been more certain of the expected behavior. Now, it's not always the infrastructure considerations. The other significant aspect that we have to consider is how the on-premise model does not measure up to the geographical distribution. As Lisa said before, Internet is growing, applications are getting hits from all over the world. And in order to satisfy the user performance, we need to have simulated environment from different geographies. And as you know, load generators are important components of performance testing. And in case of applications where higher volumes are involved, higher transactions are involved, higher concurrencies, we always need to have additional hardware to scale them up, which is mostly not a scalable model.
Great. Thank you so much, Shirish. So these are just some of the limitations of the traditional on-premise performance testing approach. Now, in the next slide, I'm going to share with you how these limitations can be addressed by using the cloud infrastructure. The cloud can help us scale for higher volume, higher transactions, and higher concurrency quickly and affordably. It helps in addressing the limitations that Shirish just discussed with you and offers some distinct advantages. The first one being the infinite computing power that the cloud offers. It has the capability to simulate millions and millions of users from thousands of instances. This helps in testing the applications with production data volumes and concurrent users. The next advantage that the cloud offers is the affordability. It helps in saving the upfront costs in setting up the performance testing environment, as the controllers and load generators can be instantiated as and when required. Another distinct advantage of the cloud is its pay-as-you-go benefit, wherein you are only required to pay for the duration of the machines that are being used. Thus, planning the test can help in saving the cost for using the hardware for a longer period of time. The instances can be created and configured at the time of use and terminated after running the tests. With the cloud, we do not have to worry about the licensing costs of the software, the OS, performance testing tools, etc. The cloud is also quick and easy to set up, as the test environment can be up and running in minutes. Many of the vendors provide automatic provisioning of the load generators that help in quickly setting up the environment and begin test executions. The cloud also offers a ready-to-use environment where no separate installation and configuration of performance testing tools is required. The instances are pre-configured as load generators or controllers. In addition, the cloud allows choosing geographies where the instances are created, and this helps in stimulating load from different locations. As a result, there's much more accurate simulation of production usage of the application under test. Thus, cloud-based performance testing can be beneficial for internet and mobile applications that have a large customer base and huge transaction volumes. Though the cloud offers lots of advantages, there are a few challenges that need to be addressed as well. We'll start with data security, which is a major concern for any performance testing activity that is performed from the cloud, since all the test scripts, test data, server response, and test results are moved to the cloud. Now, another problem area is testing internet applications on the cloud, where we need to work with the client's IT department in order to receive permission to access the application from the cloud. The network latency is among the critical factors that may skew the performance numbers. Also, during the performance tests, resource monitoring and diagnostic activity is data intensive. In case of the cloud, data transfer that happens in and out of the cloud is huge and may pose a challenge. Since the cloud instances may not be available all the time, it's important to have a pertinent test data management strategy as well. We need to have a proper backup mechanism for test scripts, test data, and test results. Now, test script creation on the cloud is a challenging task, as it involves parameterization, validation, and debug runs. Ideally, script creation should be done in a local environment, and then the script should be uploaded on the cloud for full load tests. I would now like to ask this audience a question, and it would be, what, according to you, are the major challenges of the cloud-based performance testing? And your options are data security, choosing the right monitoring and diagnostic tools, test data management, and test script creation. Now, you're going to have a total of 30 seconds to respond to that question, and you can choose multiple options if you'd like. Okay, time is up, and we have the results. It looks like around 63% of the audience indicates that data security is the major concern, while about 45% agree that test data management is the critical issue. Now let's go ahead and ask our expert speaker, Shirish Pillai, what is his take on these poll results. Shirish, what do you think?
Sure, Lisa. So, I would agree with this result. There are challenges in moving performance testing to cloud, and over a period of time, we've seen some solutions to these being provided by a lot of cloud vendors. For example, security was a concern a year before. Now, however, now you can have your private cloud can set up a separate tunnel for security. And as far as network latency is concerned, it poses a challenge for internet application, and that can be resolved to an extent by statistically adjusting the response times. Also, for internet applications, inclusion of latency in the test results provides a much more realistic view of the performance numbers. Now, let me talk about various deployment models for cloud-based performance testing. We have identified the two broad categories that are prevalent for cloud-based performance testing. I shall call them as cloud model and hybrid model. As we are aware, there are some standard components of a performance testing tool architecture, like a controller, load generator, we have a recorder, and then we have the reporting component. The variations in the deployment models for the tool depend on where all of these components are placed while we conduct the performance test. Now, one has to choose the appropriate deployment model based on our needs. Let's talk about the cloud model in detail. If you look at the image on your screen, you will notice that in this model, we have moved the performance testing tool onto the cloud. And therefore, the controller, generators, analyzer, all of them are deployed on cloud. However, the recorder is provided on premise so that user can record the script, can debug them, can validate them, and then can further upload them onto the cloud for load tests. We do have an option to have the recording component on the cloud, but it might result in extra hits in and out of the cloud. So it is recommended that we keep the recorder component onto the premise and then create scripts and then move those scripts to cloud for scaling. This model is more suitable for applications which are running on cloud and internet applications. Since these are the type of applications which would get hits from all parts of the world, and cloud can help us creating more realistic scenarios. Let's take an example to understand this. So, assume an application, an internet-based application, being deployed in a data center on in East Coast, and 50% of traffic is coming through the East Coast region. You may have 20% of traffic on that website coming from the West Coast region, and the remaining 30% is coming from the Asia Pacific. Let's say the place where I belong, India. Now, to represent these user base, we can use cloud instances at these geographical locations and can load this application to have a realistic scenario. And yes, there is no hardware procurement involved. There is no capital expenditure involved. You can use cloud for cloud instances as load generators. Another benefit that we see in this model is we're not concerned about the installation and configuration of the performance testing tool. There are no license costs involved. The process becomes simplified, and we're only charged for the period for which we use this cloud infrastructure. Let's now move to the hybrid model. Now, in this case, the components of the performance testing tool are deployed either on cloud or on premise. And then, as you can see, there are many combinations possible. Let's take the most likely scenario to understand this a little better. Now, as you can see on this diagram, we have the load generators on cloud and all the other components such as controller, recorder, your reporting component on premise. Now, this model is more suitable for organizations who have already invested into performance testing labs, into performance testing tools, and already have like hardware set up within their premises. And such organizations or such softwares, if there's a need for them to scale quickly or conduct some performance tests on higher concurrencies, this model will be useful. Many times the performance testing is done within premise to get not only to get performance numbers, but to also identify performance bottlenecks. In case we require to test in applications with peak volumes, or some applications with more transactions, we can choose this model. Since the controller is deployed within premise, we can use the integrated resource monitoring feature of the tool. We can have the diagnostic utilities deployed within premises, and which would help us identify performance bottleneck. This also helps us, any security concerns over the crucial data which remains in-house in case of controller being deployed within premises. And since the data is archived locally, we can use it anytime, can refer it anytime for future purposes. In case if we have diagnostics and the monitoring onto the cloud, there would be a huge data transfer in and out of cloud. And every time that happens, it results into a cost. So it is advisable to have, in hybrid model, to have the controller and your monitoring diagnostics into the premise.
Thanks, Shirish, so much. I now would like to take the audience through a real-life case when we helped our client with performance testing using the cloud. The client is a leading provider of workforce management solutions ranging from payroll, leave, schedule, among others. The client offers performance benchmarking services to its customers, wherein the performance testing activity is conducted at their customers' facilities. However, our client approached us to help them with a more affordable and flexible solution for their customers. Impetus suggested using SandStorm on the cloud. The recorder component was locally deployed in the test labs to create and verify test scripts. These scripts were automatically uploaded to the cloud for test executions. The client exposed the application to the cloud by setting appropriate permissions in the firewall, and the performance testing could be easily completed in time for all the business scenarios. The network latency was adjusted based on the network correction factor identified with the help of a tracer utility. The solution really helped our client to increase customer benchmarking activities, and this in turn helped in achieving higher revenue and customer satisfaction. Now, I just want to recap a little bit here. So far, we've discussed the benefit and challenges of the cloud-based performance testing and the various deployment models to address these challenges. We also shared our real-life experiences with this approach. Shirish is now going to go ahead and share some of our recommendations that you really should consider while moving to a cloud-based performance testing model. Shirish?
All right. So I'm going to share some of my recommendations that can help you if and when you decide to move your performance testing initiatives on cloud. As we know, performance testing model has been standardized over a period of time. There are standard set of processes that we do while conducting any performance testing assignment. So we start with goals, we start with requirements, then we have artifacts, and we choose tools, set up hardware, we run some tests, tune it, we run some exploratory tests, we identify bottlenecks, we end up having some benchmark numbers and whatnot. So what exactly would change when we move on to the cloud, or if we have to choose cloud? So let's look at these factors. If we are looking at moving our performance testing approach onto the cloud. Now, one of the important activities is to understand the performance goals and objectives. In use cases or scenarios where we do not have certainty on the peak usage, it is prudent to opt for cloud strategy. And moving to cloud saves us from capital expenditure and effort for procuring additional hardware, if in case our existing hardware cannot match the peak usage. Alternatively, if in case if the peak demand does not reach the expected capacity, we might end up spending unnecessarily on the hardware. The elasticity from the cloud infrastructure provides us a mechanism to deal with this uncertainty. We also need to think from the end user perspective. As we discussed before, cloud-based application, internet applications are accessed globally. There are millions, billions of users, hitting these applications. And to simulate realistic workload patterns, we will have to have users distributed from these geographical locations. We also have to look at the type of the application. The applications that have high concurrent users, high transaction volumes, big data involvement, particularly mobile applications, where we never know from couple of 100,000 when I would go to millions of users. You also need to choose an appropriate tool, model, and vendor for our cloud-based performance testing methodology. The models and tools should be chosen based on the type of the application, user base, non-functional requirements, scripting requirements, test data management, as we spoke, and so on. Another thing to look at is that the cloud environment is not shared. Different vendors have different mechanisms of providing the virtual instances on cloud. In case the underlying hardware is shared, we have to analyze the performance and see what the resource consumption is. Any unexplained changes in performance may be attributed to either shared resources or the cloud provisioning tool. Lastly, to fully leverage the cloud for performance testing, one should also have continuous performance management in place. Performance testing can be part of continuous integration that automatically execute critical test scenarios, for each intermediate build that are being spun off. The process may use automatic provisioning to generate controllers, generators, instances based on peak usage of the application. In fact, we created a similar framework for one of our clients where we created JMeter scripts on a cloud environment, and we used Hudson as a continuous integration tool to execute these scripts. So these are some of the factors that we should consider before we decide to move on a cloud-based performance testing model.
Great. Thank you so much, Shirish, for these great recommendations. Now, I would now like to introduce our audience to SandStorm, our enterprise performance testing tool. SandStorm can be deployed on the cloud, and using the solution can help reduce your performance testing costs by 60%. SandStorm is pre-configured on the cloud instances and offers a ready-to-use test environment. Moreover, the test scripts can also be created locally using the recorder and automatically uploaded to the cloud before running the tests. SandStorm supports multiple protocols ranging from the web, mobile, and email like HTTP, HTTPS, Flex, Silverlight, Java Applets, OMA IMPS, WAP, WV, SMTP, etc. It offers integrated resource monitoring for most of the popular apps, database servers, and operating systems. It also provides the user interface wizards for script creation and configuration. Plus, the analysis dashboards provide a summarized view of test results with drill-down capabilities to identify performance bottlenecks. To know more about the product and to get a free evaluation version, please go ahead and visit our website, sandstorm.impetus.com. Well, it seems that we have already started receiving some of the questions from our audience, and I just want to remind the audience that you can send in the questions using the chat window. But before we move on to the questions, I would just like to introduce Impetus Technologies to our audience. Impetus offers product engineering and technology R&D services to technology companies and ISVs. Our experience spans the domains of performance engineering, cloud, testing, large data management, data analytics, mobile, SaaS, and social media, among others. We offer a holistic approach to performance improvement across the entire software development lifecycle. We assist organizations in optimizing their system operations and provide high-performance planning, testing, and real-time performance monitoring services. We also help companies resolve a host of performance-related issues and define SLAs for applications. Now, it looks like we've received some great questions from the audience, and I'm going to go ahead and I'm going to direct them all to our expert, Shirish, right now. Looks like the first question is, can you describe in more detail, that in what ways cloud can be used for performance testing of intranet applications? Shirish.
Sure. Interesting one. This is, it is very much possible to test intranet applications from cloud. One of the prime candidates for performance testing of internet applications is applications which have been used by large number of users, have high concurrencies. Let me give you an example to understand this better, how we can test this. So one of our clients, who is in Fortune 100 company, have offices all over the world. They have offices in China, UK, US, of course, and many places in Asia as well. They have their, one of their enterprise labor management solution software deployed at a data center in US. And all of their employees across the world access this application from different geographies. Now, this application is a right candidate for performance testing of this internet application. One of the challenges that we see is network latency. The way we can handle this is once we get the response time, we can use various network utilities to find out what the network latencies are, and then we can statistically adjust our response time to get the real numbers. So in a nutshell, yes, this is very much possible to test internet applications from cloud. I hope this answers the question.
Great. Now, our next question asks, you mentioned about SandStorm during your presentation. How can we use SandStorm on cloud? Shirish?
Sure. SandStorm is an enterprise performance testing tool that offers features that are comparable to any industry standard load testing tool. We offer Recorder as an independent module where one can get that component installed locally and can create scripts, debug them, validate them, and then push them to cloud for performance testing. The controller and all other components are part of Amazon instances which are there on the cloud, and we can use load generators on cloud to scale the scripts for whatever application that is under consideration. So that's how we can use SandStorm for performance testing on cloud.
Okay, and we've got, looks like one more question right now. They ask, to use performance testing on cloud as an end user, should we have some knowledge on working with clouds, creating instances on clouds, etc.? What do you think?
I would say it's yes and no both. Yes, in the sense where there are a lot of vendors conducting performance testing on cloud. There are multiple solutions available. Few of them require the user to have knowledge of cloud instances. Many of them need the customers to have credentials onto the cloud. And many others have a lot of provisioning facilities where you may not need to know anything about cloud. You just hit the URL, get your controller and your tool and your generator set, and rest everything is taken care of automatically.
Okay, and it looks like another question just came in. It asks, does SandStorm support management of testing for mobile devices like Android handsets or iPhones?
Sure. So SandStorm does support many of the mobile protocols, starting from OMA IMPS to WAP to Wireless Village and so on. In fact, we have a couple of clients where we have tested this to around 60,000 concurrent users. And so in a nutshell, yes, we can load test a mobile application using SandStorm and using SandStorm cloud infrastructure as well.
Great. Those are some great questions. Thank you, everyone. And it looks like that concludes the question and answer session right now. I just want to thank everybody for joining us today. We truly hope that this discussion was a learning experience for you all and will add value to your performance engineering initiatives. If you have any questions, please feel free to email us at inquiry@impetus.com or go ahead and visit our website, www.impetus.com. Before we go, we'd like to inform you that you can actually meet us at the Star East 2011 at Orlando from May 1st to the 6th. Our expert speaker for today's session, Shirish Pillai, will be addressing a session on performance testing of mobile apps on May 4th at the conference. Once again, thank you for joining us in this session today. Bye-bye.